let's watch our model train now. Hopefully all went well. Nope, of course not. Let's see here. Unrecognized argument callback. Is it callbacks? It's with an S. Oh wait, no. This is embarrassing. We never compiled the model. Right? Yeah. You should always. How do I put this? We need to actually do the training part. We need an optimizer, which is gonna, in this case I'll use the Atom optimizer, and how we're actually measuring the loss. So we have 10 classes that need to match 1-to-1 in a sense. So you can like use a mean squared error, or there are many other different kind of loss functions you can use for evaluating how your model is doing. But for something like this, a categorical cross entropy is the way to go. And the metrics we want to see are metrics, yes, with the S, is accuracy. Yeah, do not forget to compile your model. Yeah, training it before compiling it, that's certainly not going to work out. Okay, now let's run it. Okay, I spelled accuracy wrong. A-C-C-U-R-A-C-Y. Okay, let's do this again. Alright, so you see I'm training it with my GPU. Okay, so now it's training. Alright, so this is good. So let's go over some of the things. So it's training on my GeForce 780. So you have the loss from the training set, the accuracy from the training set, then the validation loss and the validation accuracy. So the validation are the ones you really want to look at, because this was more representative of how your model will do in the real world. Whereas the training loss and the training accuracy, it's just how it's doing on this set. With enough epochs, it would eventually overfit on the training set, but then if it sees real world data, it will completely be lost. Okay, so while that's training, now I see I just did 10 epochs, so it can go quickly, and we're not doing too bad here. Validation accuracy is about 70%. Just to get an idea of like what the accuracy means, we have 10 classes, so that implies there is a 10%. There's a 10% chance of randomly guessing a class. So seeing that the model has a validation accuracy of about 70%, that's much better than random, right? It's a lot better than random. So let's visualize how the model did. So let's call this plot training. We'll take in the history variable here is actually a dictionary. Well, dot history is actually a dictionary that has all of our losses and accuracies in them. Now for me, I like to use pandas as a data. So I'll go back up here. I'll do import pandas as PD. Let's just move this right over here. It just looks better that way. Now this is not part of deep learning at all, but this is one module that I find very useful for handling my data. Let me just put a PDB here so you could see what I'm talking about. Okay. Alright, so we already trained it, so let's not have to retrain it again. We can actually just load our model from memory now. So we could do net.load weights. And what was the name? So if you go back into the console, let me do an ls. This is the model we just trained with 16 filters, with a kernel size of 5. Pooling size of 2 and a dense layer of 256 at the end. So we'll load the weights. I should have put a PDB at the end there so we could actually view it. Alright, let's just retrain it. It was fast. It didn't take long. So I've done this before just so we don't have to do multiple training. What we're going to want is the validation loss and the validation accuracy, and we're just going to plot those. So we won't actually need this, and then show it, and then just 0. I'll plot the training. Now, before I rerun this, actually, let's run this for the time, since it's going to take some time. So we're just going to rerun it again and let it retrain. Okay, because I want to show the. Oh, I should have put a PDB at the end here so we could catch it. Whoopsie. All right. So when our model is done training, we want to actually see how good it did, and the way to do that in Keras is you could score it by evaluating it, and you use your testing set to do this. So this is data the model has never seen before, and this score variable is actually a tuple that has the test loss and the test accuracy, and then we could print test loss. Test loss. Oops. Oh, would you look at that? Accuracy. Forgot to throw the history in here. Okay, let's just make sure everything is correct here before we run this again. Because I really want to plot this so you could see how the loss has gone down, the validation accuracy has gone up. Yeah, I think that's fine. Oh, actually, no, we could have just reloaded the weights. Okay, it's a small enough number of epochs that it doesn't actually take a lot of time. When you're actually going to be training this, if this was like a real world problem where you would, although this is kind of like a real world problem, you would probably be using like 100 epochs or 1,000 epochs and have this thing run for like hours, days maybe. When it comes to like natural language processing, I know Google's their NLP ran for like a week on a lot of GPU clusters actually. But for now, just with our small training set of just I believe 50,000 images from what we saw before. Yeah, here training on 40,000 images and validating on 10,000 of them. 10 is good enough to get an idea of how to build the model and how to see what's going on and how to evaluate it once it's completed. So yes, here's the graph. So the blue is our validation loss. So right around maybe the 5th epoch. So let's look at here. Our validation loss was 0.89, or I guess maybe even about the 6th one, 0.854. Yeah, and then it went back up to 0.89 and so on. So this is the last time the model has, this is the last time the model has saved. And here on it says did not improve, did not improve, did not improve, so the weights didn't get saved anymore. And you can see the validation accuracy, which is this orange line over here, is slowly going up. So had you had more epochs, it could probably get up maybe even into the 80s. We ended off with 70. And now let's just score it. So okay, we could just I'll just run these lines here in the terminal one at a time. So this is our score, and let's see what it is. So our, well, you know what? I already wrote this code, might as well print it out. So that's our testing loss, about 87, 0.87, and see, there you go. We call this the test accuracy. Alright, so 70% accuracy. So what this means is that had we taken this model now, and like let's say we sold it to Apple, for example, and then they put it on, let's say everyone's Apple Watch, and with the camera, if they were to point it at any of these labels over here, an airplane, an automobile, a dog, a cat, so on, the model would be about 70% accurate. So let's say 3 out of 4 times it would correctly identify one of these objects that is actually being seen. So just to recap now from the start, so initially we loaded our data set, right? Took a look at it and see how much we had. Then after that, we did some of the pre-processing, which is one hot encoding the labels and normalizing. This here is called normalizing. Normalizing the values to be between 0 and 1. There we go. Then we built our model, right, which is this. And again, we could add more to this. You could subtract. To prevent overfitting, you can add batch normalization, dropouts. There's a lot more that can be done here, obviously. But for now, we just did a very simple convolutional neural network with convolutions and max pooling, and then we flattened it, and we did one dense layer, and then the last one for the number of classes. After that, you compile the model, right? You tell how you want these weights to be optimized, and what kind of loss function you're going to use to evaluate the results as it's training. And then metrics is accuracy, so that's all of this that we're seeing right here. Then afterwards, you want to save the best weight somewhere, so that's why you create a model checkpoint. Then you fit the model with your training sets. You let Keras know how much to use for validation. I did 20% here. And then you let it train, and then you take a good look at it, how it is at the end, and then this is where the feedback loop happens. Then you'll go back, you maybe change the filter size. Maybe you put this as 20. You might change the number of epochs to 100. You might make the batch size smaller. There's a lot you could do at this point. And then you just rerun it again. And this is the number that you're really caring at the end, the testing accuracy, right? That's because the testing accuracy is what actually shows how your model would have done. Well, I call that test loss. Test accuracy. Right, there you go, test accuracy. The testing accuracy is the most representative number of how your model would do in the real world. Like, if your training loss is like, let's say, almost 0, and your validation accuracy is like almost 1, but your testing accuracy is like 0.5, the last two numbers don't really even mean much anymore. So that's everything. If you have any questions, as always, let me know.